Hi, my name is Jörg Hudelmeier. Welcome to this tutorial. It's about a program of mine which is called Pi, written like this. It's a tool for drawing curves the Metafont way. Metafont is a program by Professor Don Knuth for generating character shapes as bitmaps. It is based on an ingenious algorithm by Dr. John Hobby for constructing Bézier splines. Let me give you some background as to my motivation to write this program. I am preparing an edition of a famous book which is more than 1,000 years old. It was written by a man named Hartker. He was a monk of the Abbey of St. Gall in Switzerland. He's the one on the right hand side, and you can see his name written above his head. The other person is St. Gallus, the founder of the monastery. The book is a collection of Gregorian chants for the divine office of the monks of St. Gall. You can see some text here written in an ancient script and some squiggles between the lines of text. These squiggles are called neumes and are a kind of ancient musical notation. Let's look at one of these chants. It's a chant for the Saturday evening before the first Sunday of Advent. Its text is from the book of the prophet Isaiah. Here it is in more detail. You may wonder how this sounds. Well, let's try. Ecce nomen Domini, venit de longinquo, et claritas eius replet orbem terrarum. Let's look at one of these neumes more closely. It is called a quilisma. For those who know Metafont, it is obvious that the Metafont approach is perfect for this kind of signs. How would we draw this with Pi? Here's the program. We don't use any buttons or menus. We just use an empty canvas and two of our fingers. We start by putting those two fingers on the canvas, and we get a straight line from one finger to the other. Its endpoints are marked with circles. We can do this again to obtain a second straight line. You notice that the first line loses its circles, so now the second line is the active one. When we place a single finger anywhere on the canvas, then the active line turns into a curve defined by our 3 points. This can be repeated as often as we like. At the end point of our curve, you notice a small filled circle inside the bigger circle. This marks the point to which a newly added point will be connected. By double-clicking on the curve, you can move this circle to the other end of the curve, like this. By a single click on an inactive curve, you can make this curve the active one, like this. You may change again the direction, of course, and by a triple click, both ends of the curve will be connected, forming a cyclic figure. In this case, it yields a circle, actually not a real circle, but a Bézier spline approximating a circle. When you put one finger on the curve and tap with the other finger on the curve too, then the small circle changes to a small square, like this. Afterwards, any new point is connected to the previous point by a straight line, like this. Double click and triple click with one finger on the curve work as well, like this. and like this. On the active figure you can move the points and the program immediately recomputes the shape of your figure like this. You can also duplicate a figure. Just put one finger anywhere on the active curve and a second finger also on the curve, but not on one of the circles. Then move the second finger. We can duplicate points as well. Put your first finger on the active curve and your second finger on a point and move the second finger. This way we start a new branch. The little filled circle moved to the end of the new branch, so if you tap again on the canvas, this new branch gets extended. Putting one finger on the figure but not on a circle and the second finger anywhere on the canvas, you can scale and rotate our figure. Like this. Finally, the same operation with the first finger on a circle. We can locally flatten our curve. Like this. Or we can change the local angle. Like this. Or we can do both. Like this. Then of course we want to save our figure. For this purpose we click at the bottom where we can read pi put. If we just hit the return key here, then our figure is saved under this name. We can also give it another name of our choosing. Let's call it my first figure. And then hit return. Then a file myfirstcar.py is stored in your download directory. We can open it like this. It opens in TechWorks. It's a hybrid file. It's at the same time a Metafont file. You can see it here. And a PDF tech file. And a PDF file. As you can see, my TechWorks has three engines corresponding to these three file types. One for running PDF tech on our file, one for Metafont, and one which does nothing but just displays the file as a PDF file. So let's try. Let's compile this with PDF tech. It looks like this. Let's compile it with Metafont. Looks like this. We can also reopen our saved Pi file by just dragging it onto the canvas like this. It's in downloads. My first figure is here. Okay. Finally, we can drag a picture onto our canvas to draw its contours. Let's take our quilisma like this. Now we can draw its contours. So let's start like this, and then we just follow the contours. So something like this. Okay, let's save it under the name of quilisma. Here it is. Sometimes it's a good idea to look at it again on a neutral background like this, and we can do some corrections like this. Maybe, okay, that may be it. Now unfortunately, to store it, we have first to erase this one, otherwise it gets another name. Okay. Now let's look how it's done in Metafont. Okay. Of course, one would want to have another pen, an elliptic pen. Rotate it by some amount. So, okay, let's compare with this thing. Okay, quite close. So if you want to try it yourself, there's no installation of any kind. You just open the file py.html in the Microsoft Edge browser. Thanks for looking at this tutorial. Goodbye.